Hey everybody, today I've added an attack type system to the game. I've borrowed concepts from other games, but I've also got some new ideas I'm planning on implementing as well. Later, I've got something really cool to show you guys, so make sure to stick around for that. But first, let me catch you all up to speed on the stuff I've got done already. So, any weapon is going to have one or more of the following three attack types: slash, thrust, or strike. You can see which one you have selected by hovering over the tooltip, and cycle through them by pressing a configurable hotkey while hovering the tooltip or holding the item in your hand. The attack type you have selected can affect all the stats of the weapon except elemental spread, so changing attack type is almost like getting an entirely new weapon. But what are these two stats here? I looked to real weapons for inspiration for this project, so I did some research on how melee weapons in real life function based on their form and material. I would definitely recommend doing your own research if you're interested, but the main two things I picked up on are the importance of weapon reach and the misrepresentation of damage. Reach in Minecraft is too binary for how influential it is on combat. Having more range than an enemy usually means that you can kill them without them being able to hit you, unless they're fast enough to dodge your crosshair or get in before your attack timer's up. To fix that, we need to bring down the strength of having high range. First, we're going to introduce a minimum range value. Minimum range represents the minimum distance the target must be from the player in order for their weapon to be effective. If the target is too close, then the damage is reduced by some value defined in a config file. Usually, high-range weapons like spears and halberds will also have a high minimum range to compensate. But we also need to give short-range users a way to get in close. For that, define a rule that says any attack at less than half strength doesn't incur knockback. With these changes, we give opportunities for low-range weapons to get in close, and give them a tangible advantage if they actually manage to do so. Lethality is a representation of cutting, piercing, or striking power. But isn't that just attack damage? Maybe. Attack damage doesn't have a set, real-life counterpart. It's just a video game stat used to balance weapons. A diamond sword is probably just as sharp as an iron sword, but having higher attack damage is what justifies its higher rarity. We can keep this balancing aspect of attack damage by introducing lethality. If we tried to accurately represent a spear and a dagger, there's no reason the spear should do more damage than the dagger, since it's essentially just a dagger tied to a stick. However, since we've introduced lethality, we can give the dagger a little boost so it isn't completely obsolete. In this system, lethality is a stat that affects each damage type differently. For slash, lethality increases damage by a percentage. For thrust, lethality gives percentage armor penetration, and for strike, lethality does a percentage of the target's HP as extra damage. You may remember in my last video that I removed vanilla armor toughness functionality. Well, armor toughness is going to come in here as a way to mitigate lethality. This way, armor toughness has a clear purpose that's obvious to the player. So, how do weapons know their attack types? Well, just like the elemental system, we have to tell them manually using JSON files. You might remember from the last video that I said I wanted to make a system for auto-generating item stats. Well, I've gone and done that, and here's how it works. Weapons, as I see it, are defined by two things: their material and their form. The form of the weapon will determine by name. So things like sword, axe, and shovel get their own entries in this JSON file which stores all weapon names. The form of the weapon provides which attack types the weapon will have, and the amount of material that's used in its main component. For each attack type, the user will need to define a few things: the percentage of effective weight, which is how much of the weapon mass is behind the attack, the minimum and maximum reach distance of the attack, and the percentage of attack speed to use for the attack. Size is measured in cubic inches. For materials, I had to do a bit of research about how the properties of different metals affects weapons. I decided that there are going to be 4 properties that are going to be the best for this: weight, hardness, toughness, and flexibility. Weight is measured in kilograms per cubic inch. Hardness is a measure of how resistant a material is to getting dented or scratched. Diamond is an example of a material with high hardness. Toughness is how well something can take a hit without breaking. Generally, hardness and toughness are inversely proportional to each other, meaning as one increases, the other must decrease. Plastic, for example, has high toughness, as it's nearly impossible to shatter, but has low hardness because it scratches and dents easily. Since we're operating in a video game world, we have the opportunity to make neat fantasy metals that might not follow rules like this. Flexibility is, as you might expect, the ability for a material to bend without permanently deforming. Each material is stored as its own JSON file, because with a large amount of mods, there might end up being a ton of material types. Inside each material file, the user can define the properties I just mentioned. I also put the default element spread here, because I thought it made more sense for elements to be defined by the material rather than the form. With data for both form and material, we've created a set of rules that most items in the game can follow to generate stats. I say most, because there's always going to be some items that don't follow typical naming convention. This is good though, because a really unique and cool item is always going to have its own special name. For these items, the user is going to have to input data manually. Let's talk about what makes attack types truly unique. Other than just affecting the abilities of a weapon, attack types also have different effectiveness against certain kinds of armors and mobs. Zombies, for example, may be more vulnerable to slash damage, and skeletons might take less damage from thrust. Also, you may have noticed this red dot earlier. This is part of early testing for a system I'm going to call custom reticles. Custom reticles are my way of interpreting the angle and direction of weapon attacks. In vanilla, this is done only with swords in the form of sweeping attacks, and a mod like Better Combat implements animations. But sweeping attack feels like a band-aid fix, and complex animations don't really fit the vibe of how I like to play Minecraft. So what I want to do is draw a custom reticle depending on the weapon and the currently selected attack type, to represent what is in the path of the weapon's swing. Instead of sweeping edge, which just hits whatever's around the target, we can use this reticle to organically hit whatever's actually in the weapon arc. For thrust, we can give some kind of punch-through effect. So what does the red dot have to do with custom reticles? Well, while it is possible to draw a shape on the screen, there's no way to just ask Minecraft what mobs are within the borders of that shape. Instead, what I'll do is draw whatever shape it is that should be the reticle on the screen, and then fill that shape with evenly spaced dots. These dots are basically just duplicate crosshairs that can tell if they're looking at a mob. The more dots we use, the tighter our quote-unquote net will be, but also the more impact there'll be on performance. Luckily, we don't have to use that many dots to achieve a decent level of preciseness, because Minecraft fortunately doesn't have any microscopic mobs. The reason this one red dot was such a breakthrough is because there's a lot of complex math, well, complex for me at least, that goes into accurately getting what this red dot is looking at. It took a long time to figure out, and invaluable help from this guy on the Neoforge Discord. Again, this concept is still early in testing, so unfortunately I don't really have much to show you guys yet. I've been pretty busy lately, so I just wanted to get an update out to show you guys what I've been working on. I'm hoping with the combination of stat changes, mob weaknesses, and custom reticles, attack types will feel like a truly unique system, and not just some arbitrary number changes. Anyways, if you made it this far in the video, thanks so much for the support, and hopefully the next video won't take so long.